fancy there. Now I'm going to forget. And I'm going to try to play something and it won't play. All right. I think we are live. And that's fine.
We are good.
Okay. So a couple things from the show on Tuesday. Last night I did a full review of the code and it actually was working. The tool calling was working. It's just the model I was using wasn't making a tool call for that prompt. So I changed the prompt to force it to make a tool call and it all sort of worked.
That was the issue with between the branches. Or
That was the issue where we had the fantasy provider working
yeah.
and it was giving us everything, but then we didn't see like the tool call happen.
Oh, okay, that was there.
But it
Okay.
wasn't, the model wasn't making a tool call because I moved the prompt over to my little basic example, changed the prompt, forced it to make a tool call, and everything was just like working. So I cleaned all that code and I've created a PR for that. I don't know how long it's going to take for them to, they have to add tests and stuff, but they do that. So
Gotcha.
we'll see. And I added a cronk folder in the examples. So we have our own sort of examples. Anyway, there was a lot of code there, bro, and yield calls. And
Yeah.
I don't know what after that did. I just got rid of else clauses and cleaned some stuff up and kind of left it for the most part the way it was. So that was kind of cool. So today I want to do a couple of things with the cronk project. I want to build a small example that focuses on the ISMA APIs specifically, which is what cronk is built on. I'm going to do a quick architectural diagram that I want to add to the project.
Okay.
And then build a really simple using the raw APIs to show you how prefill works and then the batching and the decoding and all that. And really simple basic. And then that will give you a general sense of the complexity that cronk has to sort of put on top of that to create a model server and everything else that it sort of does here.
Gotcha. Okay. So like super low level.
As low level as a cronk developer could go, I guess would be it. So what I'm going to do, and we're at version 1.11.1. It's a pretty solid version now, thanks to Florin. We've been able to find some bugs and fix some things, and Florin's really good on the performance side. But it looks like we're actually faster than Olama right now too, which we should be because there's no Sego or anything involved, you know. All right, so dude, we have like nobody on, which is really rare. We usually have like 3 or 4 people on.
There's
Oh, there are some people. Okay, because in the comments I don't see anything, but that's fine. I just said that just to validate that we're live or something. Because I mean, I know it's not a popular show, but we always have a few people. All right, I'm just gonna add this right now because I want to give myself and everybody sort of a mental model of how this is all structured, and then when we write the new I'm gonna call it an ISMA example.
Okay.
I think we'll better understand what's happening here. So at the lowest level of this system, we have, I'm going to use capital, Llama CPP. So Llama CPP is a C library that is actually the engine that does everything. All right.
Okay.
It is able to work with the models themselves and do the inference. Right. So, you know, our models sort of sit behind here, and Llama CPP gives us that full sort of API to interact with that.
Got it.
Now, when the Olama people wanted to build what they built, what they did is they built essentially a Sego sort of API on top of it. So they basically mapped the API of Llama around Sego. And Sego, though, on one time, I think Olama is going to see some performance improvements in 126 because they've done improvements with Sego in 126 of Go. to
Okay.
help speed this up. There's always some sort of marshaling and mapping that has to go on at a low level, like stack frame level stuff.
Got it.
So the Go team has made some improvements here, which Olam is going to get some really good benefit of. But we didn't go in that direction because that's a lot of work. You have to build all the Go types yourself. You have to do, it's a lot of work. And because of that mapping, there's a new version of Llama CPP that comes out almost like 10 versions every day.
Oh, wow.
I don't remember what version Olama's on right now, but it is way behind. It just can't keep up. Where we're able to use every latest version of Llama CPP. So anytime I run,
So Olama is built on top of CPP.
yes, it is right
Okay.
now. It is built on top of it, but they built a Seago API on top, which is really rigid.
Mm-hmm.
So if I were to even run, if I was going to run the example chat, right? When it starts, you're going to see here. So you can see here that we upgraded already. It was at 7664. We're now at 7676. So just overnight alone, there's been that many releases.
Wow.
I love that they release as fast as they do. I'm releasing Kronk almost on the same sort of schedule. See, they don't use for semantic versioning though, right?
Mm-hmm.
But you can see how quickly it's constantly changing, iterating, and every once in a while, like on Tuesday, they break it.
Yeah.
And Ron, luckily, is on top of it because his tests are always validating the next version. And Ron saved us on Tuesday because he had already published a fix.
Yeah, I remember that. Okay.
So we've got that. So so you can see, like, even by the end of the show, if I run this again, you're gonna see this will probably have been updated at some point.
Another version.
Okay.
They're on top of it.
And the part of the Kronk system allows you to auto upgrade this every time, or sort of stay fixed if you wanted to. I'm always upgrading it. Okay. The czar folder is for things around like configuration, so Go code per se. Okay. So now we didn't want to do that. We could have done that. We didn't want to do that. We want to be different. So this is where ISMA comes in. And ISMA, we can call this a non-SIGO API. Maybe I'll put ISMA first. It's a non-SIGO API to Llama CPP. So essentially, it's a raw mapping of these C functions into Go using a couple of other lower level packages that know how to map. Think of it, we call it an ABI. So have you ever heard the term ABI?
ABI, no.
So ABI, computer science, is the application binary interface.
Okay.
It's at its lowest level, how, let's just say, functions call each other. How things are put on the stack, the order that things are put on the stack, the way the stack is unwound, right? Every programming language gets to define its own ABI, and programming languages sort of do that. The ones that keep that ABI as close to C as possible, like a Python, like a Go, right? Have an easier way of having language to programming language sort of interactions at that binary level. Okay.
Got it.
So there's an ABI there. Now, if you look at ISMA, all right, again, from a non-SIGO perspective, then what you're going to see here, let me just find, see if there's a good file I'm looking for something specific in this package here, okay? So instead of going with SIGO, Ron is using this crazy package,
Here go binding.
FFI, which is using Pure Go, okay,
instead of SIGO,
to be able to make function calls from C binaries, right? A library is a binary without CGO. Whoever did this work, super amount of drugs, way beyond my page, right? Beyond my pay grade right here. Okay. But so thanks to PureGo, okay, like here's the dynamic library, right? And being able to map there's C libraries have headers that give you all the type information. So leveraging all that.
Yep.
So PureGo at its lowest level using FFI, right, gives you a tiny bit of higher level. I don't know if there's an example here. Okay, so if you really wanted to sort of map out Zima a little bit more, right, what we could say is, let me cut this, put it out here for a second, that from a Zima perspective, you have, right, yeah, whatever, PureGo, right, here, that, and then you have this FFI package, right? And then you have, okay, really? That's what you're going to do? I think there's a way to, why do I not see? Oh, here. All right. And then you have essentially Yzma on top of that.
Okay.
Okay. And that's giving us access to Llama CPP from a Go perspective without needing CGO. And it's just inherently going to be faster, which we've already sort of seen in some small performance tests that Florin and I have done.
Okay.
Okay. Now, we're going to do some Zima API stuff today at its lowest level just to see like how inference sort of works. Okay. But when Ron showed me this, I freaked out because I went, oh, okay. So now what we can build is Kronk. Now, Kronk does have an SDK, right?
Okay.
And the Kronk SDK, the high level SDK, is sort of built on something else that I wrote, right? Which I just call the model, we'll call it the model SDK.
Okay.
So the model SDK is an API that does all the Yzma calls and stuff for a given model that we're going to work with.
Okay.
And then there's a Kronk SDK that sits on top that essentially gives us all of the concurrency features that we need. So working with multiple models and that sort of stuff. So you can think of somebody, I made this public, so somebody could use the model SDK directly. Think of this as a raw API.
Yep.
And then to add support for like concurrency and just a little bit of a higher level API, you have basically a Kronk package. So if you look here, SDK Kronk model.
Yep.
Okay, that's what you're seeing here.
That's the SE. Okay.
And I've made sure that these packages are self-contained in terms of their imports. So I'm always looking at the imports. Now, you can see here that this Kronk is using some tooling packages because you need to eventually build some tooling on top of this, but we'll talk about that in a second. So people can code here, obviously. The model SDK is using this, right? Like the idea is the model SDK touches this.
Yeah.
All right. And just like now, thanks to Yzma, right, we can go through and do that.
Okay.
And if people want to build their own applications, ideally, this is where people should be, right? I want people, right? Like
The highest level.
right. This is your, this is the people's API at the end of the day, right? Like that's what we want here. All right. Use Kronk and you get a whole bunch of engineering for free. Okay. However, this API is kind of raw still a little bit because if you look at new, okay, and you look at the model if you look at a model config, okay, it's asking for model files and project files if you're doing media and all that. And it's asking for where these files are on disk.
Yeah.
So what happens now is you have to download these models and deal with downloading is hard, right? And
Yeah.
deal with that. And that can be very much in the raw. So you want to build some tooling on top of all of this to make this easy. So we have a bunch of tool packages that I would argue sit on top of Kronk, but at the same time, you saw here already, right? And so if I look at all of the imports for model, we shouldn't, I don't think we're going to see tools anywhere. Let's see. We do see observability. That's fine. Okay, models, tools. So, so we have the models package here. And we're using the models package specifically to check model integrity there.
Yep.
Okay, fine. So we got llama observability,
Llama.
right? That makes sense.
Yep.
That makes sense. Okay, about that. So we have one situation in the config, right? If we were to draw this, right? Let's just do this for a second. There's a set of tools packages, right? So one of them here was called the models, right? That's the models API. But as we saw, the models API is also being used by Kronk. And we're using that to check model integrity, right? I put it in here. Now, one could argue, and maybe this is what we should do, because I really want to minimize these sorts of imports, that maybe the API that we're using here, let's go back and find it.
There, yep.
Right. This is doing a bunch of stuff related to API. I'm looking at what it's using. Right. So let's see what happens if I do this. And this is why I'm always looking at imports. Okay. If I move that here, okay, and I call this model, then this can just be check model, right? That goes green. Now, here's a problem, right? These just went red.
Yeah, they use.
Now, I may have, what I might have now is, let's see. I'm worried about the cyclic import issues that can happen sometimes. Okay, that's good. And then we're doing some model checks here. So much better, right? Because this is really the relationship that I kind of want to have. These are tools, right?
Yeah.
And so this is perfect because this was already importing model at some level. So ideally, we move check up here. And now this is a better diagram in that case, right? So yay for imports. I'm always looking at imports. So we've got the model API. These are a set of tools, right?
Yeah. Okay.
We've got, when I was looking at, so no tools are being used here. I really want this API to be self-contained outside of observability right now. And the reason I moved this under SDK is we're also using this in the Kronk model server. So it might very much be too that SDK observability, that these things maybe do belong under model. We should consider that maybe.
So the check.go that we just moved, the significance of moving that is now, it wasn't really being used as a tool.
I feel like it shouldn't have been depending on, if we're drawing this diagram, right, and we're doing these layers, arrows should only be going in what direction?
Down, not
should
up.
only be going down. We had an up arrow. So that's what was bothering me there, right? And so if we want to keep a clean architecture, we just want these things going down.
Oh, okay, that makes
Now,
sense. It was going up because the tools are sitting on top.
That's right.
Okay.
Now, observability is used by both the proxy, the model server, but technically, even though I put, say, observability under SDK observe, right? We could argue that maybe this belongs also under model because model needs these things. Now, the question would be, do we cancel that, right? If we want to create the right relationship here, is that the right relationship, right? Where this, and this is things that I do at night when the TV's on and I'm like,
and you're just sitting there
I'm thinking about like where things belong and all that. SD.
No. SDK, yeah, that one. SDK.
Sometimes it's just good. Just let the tool do it.
SDK observe metrics.
All right, let's just do it this way. Give me the relative. That's really where it is. Okay, so it is having a hard time finding that, but that's okay for now. Just wait a second. This is going to be under
SDK cronk.
Cronk is the namespace. SDK. Oh no, I put it in the wrong place. It's this right here. Hold on. Give me this. Copy that relative path up to Cronk. Okay.
Cronk SDK model. Okay.
So if I do that, and I do this, right? What else goes red? Now I would expect this to go red, but I think that's fine, even though this is going to be hotel. So I'm going to do this right now. Because it's, we're still saying that this is part of specific model stuff, right?
Okay.
So I think moving that package there, and we'll go back to the diagram in a second. And I haven't even really implemented OpenTelemetry just yet. Now that gets interesting that I've got OTel in auth related to model. See, this is where it feels better. This is a place here now where it feels better to have it under an SDK as opposed to, because I'm using OpenTelemetry in the auth service.
Not just model.
Right.
So
right.
It's getting used by two different.
And
yeah.
Like this is a little bit more generic, right? See? And so now suddenly the OTel doesn't make sense in terms of putting it there. Right?
Okay. The metrics is what we're using in the model, right?
We're using metrics too in the model, but
we're using them both. Okay.
Right? And originally I had it completely just under SDK, didn't I?
Yeah.
Originally I had it here, right? Just completely under SDK. So if I go back, let's even fix model here for, should just find it. So you see like why I put it sort of not under tools,
yeah,
but under sort of like a Cronk SDK. So an extra sort of support. Now, if it was just being used by model, then I think
it would make sense being there. And
it would make more sense being there. Sometimes you got to do this crazy shit just to sort of feel it out. All right. So that's why, if we come back here for a second, You have cronk, observability as part of the SDK, security, and tools, right? And then we can think of, if we're thinking about the SDK, here's cronk. This is where I want people sort of using it.
Yeah.
But you can see that we have some observability packages that work in a couple of places. You're not going to use these directly.
Mm-hmm.
These are more support for the things that we're doing.
Okay. So then, like, what would make them a tool rather than just general SDK
Well,
alongside Chrome?
that's a great question. But I'm now wondering if because they really shouldn't be used directly, if it doesn't belong under cronk. In other words, create the relationship here where it is cronk observability, right? And
Yeah.
where it's not part of the SDK per self. It's a package that's really specific to, say, cronk, right?
And we're using it up in the CMD auth also.
Yeah, but I think it's fair then for it to be here. Because then I'm not suggesting that this is something a person should use. When things are out in that it's got to be hotel. When things are in that sort of outer layer, you're kind of saying that this is an API that's sort of available to you.
Yeah, and it's really not. It's more available to Kronk.
It's really
and
not,
then you're
right?
using Kronk.
It's essentially. And I think you want to sort of create that relationship that this is really cronk. It's SDK, but it's really cronk specific, which it is, right? It's metrics around how we're doing everything from how long prefill is taking to how long it is taking to load a model into memory. So if I do that by hand, then I think what you're going to see here is, now I would say the same thing as with security. Shouldn't really be using security, is really around securing cronk, right?
Okay.
So I could put security there, and this is not a problem. Now it's going to be SDK cronk security.
Double.
Yeah, that didn't help for sure. And it's going to be cronk. And you're actually using cronk. Nice. Sometimes also it's nice to see where things are being used and if that makes sense.
Yeah.
And right now I think it does make sense. Now, this shouldn't break anybody's programs because they shouldn't have been using these APIs anyway. But now we're kind of creating a documentation that says, you know what, when a package is inside of another package, the general idea is you shouldn't be using it, right?
Yeah.
So this is like cronk security. So if we do that, come back here. I still have one more.
There. Yeah.
I don't like using AI agents and replace for this sort of stuff. I want to see it.
Yeah, because then something can get replaced that you don't want.
So now at the high level SDKs, there's two of them. You can use cronk and you can use tools. Okay. And then if you want to go lower level, you can use the model API, but it's lower level.
Mm-hmm.
And I think observability and security are better fits inside of here.
I think so. It makes more sense. It's not really like alongside Kronk. It's more like inside of Kronk.
Right.
Does that
Because
make sense?
now what I can do from a diagram perspective is say, let me make this a little bit bigger, right? Like, is now what you have here are the tools. There's a whole set of tools you need to make this system sort of usable. Okay.
Mm-hmm.
And one of those tools is the models API.
Yeah.
And if I go back through the models API again, right, that's okay. Like imports are allowed to go down. So essentially it is using, right? And we would expect that,
Mm.
that models, sorry, right? Cronk models, all of that's okay. We would expect that. We'd want that. And that's fine. So the models API is a set of tools that we use both at the CLI level
Okay.
and at the web service level that allows you to do things like download models, validate that the download is clean. Like though we moved that other
Mm-hmm.
sort of model check up there, which was fine.
Yep.
It's allowed to do that. Remove a model from the system, retrieve information about that model. These are all APIs, right, that we
Yeah.
need to build a bigger system. So when I start the UI up, you'll see like, whoa. And everything there will also be part of the, you see the browser interface. It's all part of the CLI tooling as well.
Got
And
it.
so if I were to show you like on disk, by default in your home directory, we'll create a .cronk. You can see all the things that we're dealing with here, like models.
Yeah.
And you can see here that a model I was playing with yesterday, which is a coding model. That's a 26 gig model. But we found on Hugging Face a file that goes with each model that tells us the SHA
Mm.
and the size.
Oh.
So we
Okay.
download that now, right? We download that, and now we can that's what that check does. It checks to see is the size the same. If
Yeah.
that file exists, it may not exist, but if it exists,
Mm-hmm.
then we can do a check at startup and say, hey, this model file you have is no good,
Yeah.
right?
Okay.
So you
That
need
makes sense.
tools to do downloading is the hardest thing in the world. And so you need tools. So that's the models API.
Okay.
You also need to download Llama CPP, right? You saw that when our little example program started
Yeah.
downloading, right? The model was already existed. We work at a URL level.
Mm-hmm.
At the tooling level, we say, hey, where's the URL? And then we do everything off of that.
Mm-hmm.
By the way, what we discovered was the download URL. We only really work with Hugging Face now. We're so specific to Hugging Face.
Mm-hmm.
But what we learned was, Florence saw this. The URL to do the actual model download is resolve. However, if you do raw here, you get the
Oh, you get that. You get that file.
So,
Okay.
you know, I started out with the idea that you could download a model from like any site. We're now very much like Hugging Face only, to a point where I'm going to have a conversation with Florin because I'm starting to wonder if we just stop asking for this part.
And just assume Hugging Face.
Yeah. I gotta talk to him about that.
But
Like, we could still accept it, but essentially, if you're not, if it doesn't say Hugging Face CO, like, reject it
just
almost at this
reject.
point. We're pretty. Let me just put it this way: this particular package that I'm showing you,
Mm-hmm.
this model's download is just completely tailored to Hugging Face right now. Now, because it's a tools API and it's not tied into the Cronk API, which just cares about where a model is on disk,
Yeah.
we could build another models tool for a different site. One could argue, right?
But Hugging Face is really like the main one, right? Like
I
it's the
don't
more
know where else you
mainstream.
would go at this point. So it's a conversation I'm going to have with Florin. Anyway, so you have a libs API. We leverage a lot of support from Yzma for this because Yzma is tied to the Llama, and you got to pull down the right one for your architecture, for your hardware, all that sort of stuff. And
Okay.
so the libs API essentially is doing that. Okay.
Got it. Okay.
And that's what we use in our. So you're also going to be using these tools, right, to do things. So if I also showed you the chat example that we just ran, first thing we do is we say install system. What does install system do? It says, hey, we got to download the libraries.
Yep.
Now there's another tools here called templates. So we have two other tool systems here. We have what I call the catalog, and we have template. And honestly, what's interesting is the template ends up having internally a catalog. So if you instantiate a template, you kind of get the catalog sort of from free there. So that's why you saw catalog, you see templates. Security is about creating tokens and things that we need in order to, there's a whole security system in here that gives you the ability to authenticate your API calls, identify with JSON Web Tokens. Are you allowed to do chat completions or embedding? Are you allowed to even create other tokens?
Okay.
Things like that, right? So there's a set of security tools here that we built. And you can see here, I almost wonder, let me look at this API while we're here. I'm wondering who uses this right now, honestly.
Up there. Yep.
Yeah, it's all used. Actually, if you think about this now, since it's only used up there, right?
Should it be moved?
I wonder if we just did this real quick. Oh shit. My finger ran out of space. My finger ran out of space. I got to start low. All right. I'm wondering if this shouldn't be an SDK, because if you think about it, nothing went red below here, did it?
No.
It only went red up here, which tells me that this is really an SDK package because it's only used.
That one didn't fix itself.
Again, imports are like everything, man. They tell you everything that you need to know. Okay. Somebody's asking about they come from a Disney movie called The Emperor's New Groove.
Yep.
Ron, I guess, loves this movie. You know, I've never actually seen the whole movie. I'm going to watch it now.
Really?
Yeah. Ron decided to use Yzma. And once Ron used Yzma, I had to use something else from the movie. So let me put this here. Okay. One more place. Okay, cool. Let's see where we are now. So you got the Emperor.
Yeah.
This is where it comes from. So that's Yzma, and that's Kronk, and Disney should be coming after us eventually. So it's all good. But that's sort of where it comes from. So anybody else that wants to contribute something new to this sort of ecosystem,
You got to pick a name.
you got to pick something out of here, man. Yeah, that's funny. And we all get in trouble together. So that's kind of cool, right? Like that ended up really just being a SDK at the end of the day for no. Now, this is where that sort of breaks down, though, being an app layer SDK. Maybe. There is a CLI tool called security that is using this. Now, that sort of tells me that, oh, but this was a tool level security. Okay, no.
So it's a different.
Maybe. We built this for security support. Did authentication. It lists the keys. It uses all that. And it makes sense because we have a CLI tool that needs to do these things. We need to be able to create tokens from the CLI tool, right? And same thing. We need to be able to leverage that here. So I think it's fine being in the app layer here. The only thing that bothers me is sort of reaching into but then again, this is an app. This is also like an app layer sort of thing because it's a CLI tool, right? And so I think it's going to be okay to put it there. The only other option would be to make it foundational, but it doesn't make sense to be. If I make it foundational, it's not really generic enough. It's very specific to what we're doing.
Yeah. I could see that.
Yeah, because this security here has the actual auth package, the key store, the rate limiter. These are lower level, right? And we must have been using it in here somewhere, right? Something here was using auth, I guess. Let's do this again. This is the best way sometimes to just see. Okay, so only that went red up there.
Nothing in there.
Huh. Let's try something. I wonder, when I moved this, none of this went red. What goes red if I... All right, let's just do it this way for a second.
Up there.
Everything goes red up there, doesn't it?
Nothing in there, though.
Nothing in here. So I'm wondering now if this doesn't belong here for a second. Nothing went red there, right?
Nope.
Now, this is providing several things. It's providing auth, but it's not really foundational auth because it's very specific to sort of what we're doing here with auth, okay? The key store and the rate limiter that we work with. So we have that. Now, what's interesting to me as I moved this is I expect this support package to do that. I expect that because it needed the auth package and this needed the auth package, right? To do that work. So I feel pretty good that this really should be, though in my regular project, I wouldn't have put it under foundation. I would have put it under app SDK because really it's just being used by the app SDK. However, I built a higher level security package that has both auth in it, the limiter in it.
So it's using those more. Okay, yeah. So I can see that.
Right. It has its own model there. It has a function to do key gen. It had its own set of tests. And this was sort of a grouping of both this and this, right? Now,
Yeah. Okay.
maybe what we do is the following. Let's fix these imports first, right? So if I fix these imports, let's fix these imports first. So that would be that. The main security. Oh, I got to fix this. That's why. Let's fix this first. I have an idea. All right. So that's that. I moved this package now under. I'll do this one last. Hold on. Let's fix this. And let's fix you. And I know what that one is, so I'm not worried about it. We'll do it last. I just have this in the clipboard. I don't want to get rid of it.
Yep.
And I want to put this here. Okay. So this is gonna change a couple times. I'm not done yet. I'm just doing it in parts. So this basically wants that. Okay. Now I'm wondering the following. What if we do this? All right. Then this becomes our security package. It makes much more sense to me.
Yeah.
This security package now is here. Interesting, right?
Mm-hmm.
And then again, because it's so specific to, let's see here. Because we've got both a CLI and a web service, I kind of don't have that concept in the service repo, right?
Okay.
So there's something here that's a tiny bit new. But let's just fix this now. Make sure all these tests don't work. I didn't expect to do all this when we started diagramming, but this has been a really good exercise.
Yeah, but it gives a good sort of like exercise into how to structure the project.
Okay. Now, see, my thing here is this isn't really foundational, mainly because we have a very specific claims structure. Well, that's just generating a private key, but right, this is just providing a higher level thing, but we have a very specific claims structure. It's not, this isn't foundational. It's very specific to how we manage this. So my brain always said was, and you'll see this in service, is auth and all of that belong under app SDK because security is a app layer concern. So what I would want to do is move this here.
And now everything, yeah.
I said I was going to move it one more time.
Yeah.
But it's really that, right?
Now it's consolidated into one security package, so.
Yeah, which again, if you don't do these sorts of refactoring, you end up with a mess because you're not thinking about
how everything sort of works
sort of,
together,
yeah,
connected.
And connected and keeping those imports down, not up, right?
Yeah.
I think that's all of it. Yeah. Oops. Just do it at security. All right. And we just got a couple more. Okay. I think that solves this problem. And now the CLI, which is, again, like an app layer thing, I'm going to let it reach into app layer SDK. I think it's fine. I think it's fair. It's going down. It is, this is an, oops, I don't know what happened, but I don't know what button I pressed there. But I think it's fine. It's still app layer concern. It's just the CLI side of it. And now the SDK has the security, which is the where it belongs with the package. And then that package has the support packages underneath. And then if we come back to SDK, now that's sort of gone, right? And you're left with really the models API, the libs, the catalog, and the templates, which I'm going to show you. There are defaults here. That's fine. And the downloader is a lower level code for downloading stuff. So I wouldn't put that in the group of tools per se, but it does sort of belong there because we use a downloader for a couple things.
Okay.
So what that now means is, let's see if I can just move this a little bit. All right, cool. And then, so then on top of that, we have essentially this. And I'm sure that catalog also uses tools models, which is fine. Tools models. Cool. And then the templates, I'm going to show you what the templates are. Templates uses model, right? Which is fine. Okay. So this is essentially our SDK in a nutshell, right? You're going to have these APIs that let you manage models on disk, your libraries on disk, your catalog and templating system, which you don't need, but it just makes it easier because right now the model SDK just says, where is the model on disk? The Cronk SDK says, where is the model in Hugging Face?
Okay.
Right?
Yeah.
So again, we go back to examples for a second. Let's go back to the beginning here. When we do an install system, what are we doing here? We're using the libs tool, right, to download the latest version of the libs. Using the templates tool to download the templates, which also in turn downloads the catalog. Now, what is that? Let's take a look at that real quick. And everybody can have their own private repo if they want. So part of the configuration, and all the new functions have a new with settings that lets you override all the defaults.
Yeah, I saw that on
So
Tuesday.
the idea here is you have a catalog system where this is what Olama has, right? Go to Olama. What does it say? It shows you all the models that they support. Okay, that's their catalog.
Yeah.
Now, you're kind of restricted to their catalog in the sense that I heard that they're using Go templates instead of the Jinja files. So somebody has to do these conversions of the templates and everything. So you need it. It's easier for people if you have a catalog. So the idea is that I have this project up here too. Oh no, I have it here. So the idea is you have a GitHub repo, and that GitHub repo has two folders. It's got the catalogs folder with a set of catalog models. I'll show you that on VS Code. And then a set of templates where the embedded template in the model is broken and we need to fix it, which we have to do here. And what happens is you have these templates. So I use my AI agent all the time to fix a template. So if you were to look at let's go back to the code for a second here. If I were to look at this example, I want to use this model here, right?
Yep.
All right, let me do it this way for now. Well, let's look at the catalog for that model. So that's a text generation model.
Mm-hmm.
So here's the metadata that we manually put together for that given model, right? And I don't want to put 200 models in here.
Yeah.
It's just a catalog of the models that people are using. And I hope over time, the community for the models they're using, like now, Florin's using this new model. I told him put it in the catalog, but we manually put this together. So that's the download URL, right?
Mm-hmm.
That's sort of the web page for that model. And then some metadata like the collection of models that Quen has, and you can see what endpoints does it support?
Yeah.
Does it support images, audio, video, streaming? Like
And this is stuff that you're putting manually in there.
put into this catalog, right?
Yeah.
And then if it's a model that has a broken template, I'll show you this one. Then you can specify the template file. And if we find it in the templates, we'll use this instead.
Oh, okay.
So here's a great example. So this is the quantized 8 model here. Okay,
Yep.
Here's the card. You see this chat template tokenizer?
Yep.
This is the chat template. All models have a chat template. This describes the input, and it teaches the model how to produce a prompt that the model understands.
Okay.
Okay.
Yeah.
You could just give it raw text, but if you're trying to do anything more, like tool calling and all that stuff, it ain't gonna work because it has its own sort of language.
Got it.
So these templates can take input and produce a standard output that this model understands. You can see it's a weird Python. It's really like a Python language, okay?
Yeah.
Which is great when you're running Python, but not when you're running Go. But because of that, and you can see how complex this one is.
Yep.
We're using a third-party package that somebody wrote called I gotta find it here. It's gonna be under Cronk models here for a second. Called this one.
Ganja. Okay.
Which I actually submitted some fixes to. This has just enough support to take this and process it with some input. So this saved my ass, because if not, then I would have had to do what Olama did and write a tool that takes this, convert it into a Go template, store that in the templates, and then you could only use models that we had Go templates for. Olama.
Oh, okay. So this saves you the trouble of having to translate.
Gives us more. It gives us more freedom and flexibility.
Uh-huh.
Now, however, every once in a while, like twice right now, that template that's embedded in the model, Ganja can't.
It just can't.
It's broken in a sense. So I go to SourceGraph AMP and I say, here it is. This is the error. Fix it. And it gives me a version that works.
Got it.
So the idea then is we save this. Olama does the same thing, bro. We save this. And then in the catalog, we can bind a model to
that one. Like this model has a broken one. This is the fixed one.
Now, again, at the low level of our model API, there's a config. And in the config, you specify the files. You can specify the thing, right? So the model API is low level. It's these tools that feed all this information. You can do it manually.
Yeah.
Okay. So you can do it manually. When we come back here and we do, so that's the template system. So here, when you say cronk new model config, right? This is the low level piece.
Yep.
But you can see here that we passed in a models.path from our models tool, right? Yep. And that's because when I called install system, right? And I said install system, and I said this is the model that we want to use. I hard coded it in here, right? You could also tell the catalog system, let's do it by ID because we already know about it. The download tells us exactly where that is now on disk. See, that's what this tells. It tells us exactly where it is on disk. And now you can use that to feed the API. So if we go back here, right, you can always use the SDK raw, and you could download your own template files if they're broken, and you can do all that. But these API tools, what they do is they let you download, store everything on disk. They let you work with the catalog system and template APIs if that's what you want. So ideally, if you instantiate a template API, it underneath the covers instantiates the catalog system for you. There's that sort of relationship. So that's why what you see here is I say new templates, and then I can get to the sort of catalog.
Templates
It's just,
catalog.
yeah, because there's no way to map it without having that relationship, right? But now these tool packages make it easier to work with Cronk in terms of models and the libraries and the catalog system. You don't need it. This is why we've been fixing imports.
Yeah.
Right? You don't need it. And the only way to say I don't need it is to keep these imports from going down, not up. Once you say up, now you're saying I need it, which isn't good.
That makes sense. Okay.
So this is a now much cleaner situation. What I'm going to do just to keep my sanity here, just let that run while we're talking. We got a whole bunch of tests that validate that everything's working, from model APIs to Cronk APIs to web APIs all the way through. And you can see here that we failed already miserably because we broke something.
Security, no such file of the path.
All right, so there's something that didn't get. Let me see something. Make. That's why we have tests. Make, install. Maybe this broke too. No, that was fine. So, oh, I moved that package.
Yeah.
I moved that package. Okay, so we got to fix that in both places. So we don't have this under SDK. We have it under here now. Edit, copy relative path. Yeah, I just manually sort of put some of this out just so I can control the order. So I did the security first, and the tools, and Cronk. Now, you know, I have app SDK down here, so I actually don't even need this anymore, do I? Because it would have done it twice.
Oh, okay. I see.
Yeah, I would have done it twice. So we're gonna gotta get it out of here too. Okay, perfect. Right, we're just gonna do it. So I'm doing the tools, then Cronk, then we're doing the SDK, and then it's just I just wanted to control it a little bit more. All right, so that's why it broke. It wasn't an import issue. It was we moved that thing.
Path
All right, so let's let these tests run. So cool diagram now, right? This is sort of where we're at with all the different APIs that you sort of need to build a system. Now, like I said an hour ago, I didn't expect this to take an hour, but that's fine. So the project cleaner. Let's even save what we've done here. Those tests are going to pass. So get add all, get commit minus I'm just moving. These commits don't matter. I mean, these comments don't matter because we're going to merge this shit anyway. Okay. Ooh.
No provides.
Okay, so something here happened to our command server app security auth. Or, as I said, this was just all going to pass. And auth test 8.2. Oh, we missed this one. What is this saying? Oh yeah, it needs itself, doesn't it?
Interesting how that wasn't red.
Because it's a test.
Oh, okay.
Because it was a test file. All right, let's try it again. Then I'll push it. It's fine. Okay, so while that's running now, it should be good. Okay, let that run. I wanted to add, I thought it would be interesting for myself even, because I'm not 100%. It's funny, I've built this huge ecosystem, right?
Yep.
Let me just do this for a minute. I've built this huge ecosystem, right? So once these tests run, I'll show you a little bit more of how all this tooling and stuff, right?
Yep.
The idea is to teach like how all this sort of works together, right?
Yep.
By the way, one person, I mean, I have a bunch of experience. Let's not go too crazy, but I was curious when we started this project here, right? I never know.
It's gotta be.
I don't know a good
months.
way of. I know. I do a lot of. Does this go backwards in time? Yeah. It's got to be a faster way to do this, but
I'll probably.
Here it is. The initial commit was November 18th. So December 18th. It's been less than 2 months, bro. It's crazy to me. It's been less than 2 months since I started this project, and you can see
a lot of work in there.
But a lot has also been very helpful using the AMP tooling, because the AMP tooling has allowed me to do a lot very, very quickly. You know, not that it's none of the code other than the front end code is blind.
I was impressed with it on Tuesday, with all that pretty complicated code, and it made it work for the most part.
Okay, the tests all pass. Good, right? Just gonna commit what's there. I'm gonna just tests passing. So okay, so watch this. I'm gonna start the cronk server. Now, every time I do that, it rebuilds all of the documentation and stuff that we have. I had AI build me tools for this stuff. But you can see when it comes up, it's looking to download the latest version. It's still the same. It hasn't changed. Then it knows everything that's currently on disk, and it's checking to make sure that those models were validated, and they were, right? We're making sure we have the latest version of the catalog and the templates.
Okay.
And now if you just go to localhost 8080, you get this website.
Oh, nice.
Yeah, bro.
I haven't seen this yet.
No, this is badass, isn't it? Now, this has been completely vibe coded, like 100%. But it's not bad. You have all the docs. So this is what gets reproduced all the time, right? I have tools that I had the AI agent build.
Yeah, that's neat. So every time you change something, it'll like rewrite it
Automatically.
Nice.
Writes it. Yeah. That's all under I don't even know where that is anymore. Oh, API tooling. Docs. So these are little programs or a program that does all the docs. So this is basically Go Doc, right? I told it to give me a Go Doc representation of the API. You have it also of the model, because those are what's important. I didn't add the tool APIs here, but I probably need to do that. And then the example codes that we've been looking at, that gets put in here too.
Oh, that's
so if I make a change to the examples, and like we're going to add another one, I'll tell it, the AI system, to add it here. You now have your examples here.
That's awesome.
Right? And then you have the docs for the CLI tooling. Again, as we make changes, it updates this. So
okay.
I had just made a change to this for, I don't know if I see it in here. I have to ask it to double check something. We added the idea that you can change the base location for things.
Okay.
I don't
Yeah.
see it in here, so somehow that didn't get updated. But you can see the full docs for the CLI tooling. I may need it to update some stuff there. And then the web API,
Nice. Okay.
right?
What did you use for the front end?
Dude, I just told SourceGraph Amp to build me
Oh,
this.
you just told.
Dude,
Oh,
this is all vibe coded. And then I have tooling that, so I don't have to pay for this over and over again.
very cool.
I just have to come back to this tools and double check that they're updating things, right? Because like this is fine. This API is really stable and it's GoDoc, but I feel like I added a new flag yesterday. I don't see it in here, so I'll have to double check that. But by having a tool that does this, I don't have to be paying for it all the time, right?
Yeah, I just can
Anyway,
use
so you
it.
got the full docs right here,
Ah,
right? And then you have the models that you have on disk and if they've been verified or not, because you might have started a download and then you've stopped it. And then
okay,
you
yeah.
can, so this is the one we were playing with here. And this is all hitting the Cronk model server right now, right? And everything you can do here, you can do in the CLI tool. It's loading the model for the first time. So that's why.
That's a big one too. It's
Yeah.
24.
Yeah. And I keep, by default, you can keep 3 models in memory at any given time. I have a whole caching system, just like Olama does.
Yeah. Wow.
But the default is 3. Yeah. No.
There's
Yeah.
a lot. There's
Uh,
a lot for
so here's all
2 months.
the metadata. Remember that card that I showed you
Yep.
on the website?
Yep.
This card? It's
Mm-hmm.
essentially what you're seeing here. You can see the models that are currently running in the server because we just touched that one. But if I were to say, show me this one, smaller model. So like if I go back and look at this one, it's fast now because the model's
Cache.
loaded, right?
Yeah.
These 2 models are running. Now, if I were to do this for a third one, that's fine because the default is 3.
Mm-hmm.
But if I now do it for a fourth one, it's going to evict. It should evict a model once this is done. The oldest one. So I imagine this is the one that we don't see.
That's a big model. 69 gigabyte.
Oh, fuck. I shouldn't have put that one. This one is a model that, actually, I've never tested it. This is a model that's sharded. There's 2 files on this one. That's,
Oh.
yeah. So I have support for sharded models when they get that big. That just worked. But you see, now we still only have 3. So
Okay, so we kicked one
one
out.
of the models has to be kicked out of memory.
When it's doing that, is it holding that? It's not holding 69 gigs, right?
It's interesting because remember I'm using a Llama API that says load model from disk. Whatever it does, I don't know, but you can see
Okay.
how long that took, right? Like
I feel like 70 gigs would take if it was actually loading 70
you can
gigs.
see here in the right. I gotta fix
File.
the trace ID for this, but allow you to pass that in. But you can see here how long that one took, right? And I have metrics for this stuff.
That's
I gotta
interesting.
fix that. I'll fix this later. Anyway, pretty cool, right?
Yeah.
And then you can pull a raw model if you have a URL.
Okay, and that's okay.
That's raw, right? And then here's the catalog system. So it'll tell you if it's already loaded on disk, what its capabilities are, if it's valid.
That's cool.
And then again, you can get that sort of information from it. But this is catalog stuff.
Yeah.
And then on the library side, you can always pull a new version if you want. And then on the security side, you can see a list of keys that we currently have available. And then you can create a new key if security is on, you can put your token in here.
Got it.
And
Okay.
and right now, it's all disabled.
Really
So
cool.
when you create a token, you can say admin which endpoints, how long. All this stuff works, bro.
Wow.
No, this is like really comparable right now to even beyond sort of Olama. It's still designed around your own personal server. Like,
Yeah.
but because of this, you could publish one for, say, a small team and say what you're allowed to hit and stuff. But at some point, I'm going to deploy this somewhere
For
with
sure.
security on. And if you don't have a token, you can't necessarily play with it. But
Oh, that's really cool. I hadn't seen this yet.
no, bro,
That's
I've
really
been.
cool.
This is 2 months of work right here. You have no idea. With full CLI support behind it and everything. So, and it's
Insane.
got the streaming and then so watch this. So that's running, right? You can start your open web UI. Where is it? Right here. Here, open web UI. I don't know why you're taking so long. You weren't doing that yesterday. Huh. I wonder if it's even running. It is running. I don't know.
Okay.
Okay, now we got it. So here are all the models that I have downloaded.
Oh, so you can hit them all using
This is the new coding model that we've been playing with, right? So I always say hello model. This happens on this open UI for some reason. Let's say it again. That first time. I don't know. They have some weird bug. Hello model. And I do that just so we've got to load it, right?
Yeah, so it's gonna take a second to like warm up.
Okay, it loaded it up. Hello. Write me a Flappy Bird program. Write me a small Flappy Bird program in Go using Vulkan, whatever Vulkan is. Dude, Kronk is spitting that out, bro.
That's immediate too.
Oh no, it's much. You can see that we're.
It's like immediate. Yeah, chunks coming in.
Yeah. But I don't do every chunk, like every 14, every.
Oh, in the log. Okay, I
See
see
every
it.
200.
Yeah.
Boom. 78 tokens per second.
Oh, and it gives you all the
No, I got the whole
metrics and
thing
everything.
working, bro. You have no idea.
This is cool.
But that's thanks to like all the work I did at Prediction Guard. I understand all this stuff.
Yeah.
So there's a little Flappy Bird program. But
That's
but
cool.
we're using we're using this tool now against the Kronk model server. Yeah, bro.
This is insane. Wow. In 2 months.
Yeah.
I feel like it's a lot for 2 months.
It is a lot for one person, but this is why I'm so adamant that we're all using AI coding agents, because it's the AI coding agent that has allowed me to get to.
Oh, for sure. Because you have the ideas now, you can kind of like
Yeah,
get 80% at least.
it's helped me, and even last night it helped me re look at all of the Llama CPP code we're going to review now, and help clean some of that up in the order of things, because I really don't understand that. I figured out the order to call things in.
Yeah.
I didn't really understand it.
Yeah, what like each.
But still, not even understanding it all. Look at what you're able to build, right? And I never would have had this without an AI agent. Like, I can't build front end.
Oh, this is great too.
And I told it I need a splash page and has these things in it. Right? Like, pretty wild. Okay. So that's a good sort of review of. This is the next endpoint I got to start thinking about too.
The responses.
Yeah, I got to think about that. But I got to look at the CLI tooling. In fact, I don't want to forget it. So let me do this first here. I've been just adding things here for me.
Nice.
Review CLI tooling docs are updating new flags, because I'm not sure it is. This is how Florin and I are sort of working out of here, instead of issues on the So Florin is gonna still play with some of this, but I have the metrics and stuff in there already, honestly. Anyway, okay, so this is what I wanted to do. I want to try to go really low level here. And from a diagram perspective, let's do if error run. Oh,
I noticed you got away from the tab completion too.
Oh, I don't use it at all anymore. It was so in my way. I just don't use it anymore. If I need help, I go to the agent. Tab completion, it's to me, it's broken. And Sourcecraft got way too aggressive. We started changing code in places I didn't even know it was changing.
Oh, when you would tab, it would just go like down in the file somewhere where you can't see.
Yeah. Do this one too. Oops. It would do things like that to me, basically, even though I just did that to myself. No, completely off. Don't use it anymore. Nada. From dot print line error OS6 1. Okay. So this is what I want to do. Okay. There are these steps that you have to take when you're going to get all that stuff sort of working, right?
Okay.
And I'm going to just, let me get this chat thing here for a second. Whether I like it or not, I already have the libs. This. No matter what, I need to call this a init. That init is a absolute necessity.
Okay.
What a init does is it's really low-level stuff to load the Llama CPP libraries into Cronk, essentially. Okay. So nothing will work unless you call a init. And you can see it's a init once do sort of stuff. So no matter what we do, basically to initialize ISMA, we have to sort of do that. Okay. Now, everything else we do though, oops, we can just sort of go really low level now. Okay. So there's going to be a model file that we're going to want to work with. I'll continue to work with the one that I'm always sort of playing with for some reason, which is this one right here. It's like, it's one that Ron was using like day one, and I've just sort of used it from the beginning. This to me is like where it all sort of, when I just want that. Okay. Model file. And then I need the file itself. I can just do like a rename. All right. So that's the file on disk that we're going to play with. All right. Okay. That's the model file. And we can sort of keep it simple. So if I were to look at new, I don't think I need anything else sort of in here other than getting into the model API now. Okay. All right. So this is some Llama stuff that we're definitely going to need here. All right. I need these default model default params for sure. So again, the only thing I want to see here is ISMA really at the end of the day, even though I'm calling this, oops, init.
Okay, but it's because it's loading all these, yeah.
You know, I can move all this out, but it's just not worth it for where I'm at. That's the only cronk thing I'm going to do. You could specify other devices, like if you have special GPU cards. That's what that's doing. We're not going to have that at all. And then we need to make this call here, right? You can see load model from splits.
Oh, that's the,
yeah. That's when we have the splitting. So the sharded. So here, this Llama 3370B comes in 2 files.
Okay.
Discovered that last week.
You think they do that just because of the file size for each one? They're
They're just
huge.
large.
Yeah.
I think what it also allows you to do potentially, and I don't know enough. This is where we need Florent, and I'm not doing this, but I think it would also allow you to maybe load these two models on separate GPUs.
Ooh.
You know, like I
But
think
and have each one work on a certain for
somehow
speed.
I again this is where like my pay grade is. I'm at an API level. This is kind of where you need Florent, but that allows you to take the splits. All right. Um, I use the word sharding because the first time I noticed this even existed, I was seeing the word sharded model, like in documentation, though,
Yeah.
calls it load model from splits.
Splits.
I didn't even know it had to be in the right order. I just did that. Anyway,
Huh.
so, okay. So this here is what we need in order to load the model in memory. Now, the thing is that this isn't thread safe. So it's this isn't thread safe in the sense that we can only really use one go routine against this model now, right? If you want another go routine doing work, you have to load it a second time. This is what Cronk does.
Okay.
The Cronk API essentially gives you that level of concurrency. So how many model instances do you want? And then when you make a call like chat or chat streaming, all this code does is it pulls a model instance out and then uses it, and then it sort of goes back. So
Okay, and this helps the performance.
it makes it not blow up because it's just not thread safe.
Okay.
So you basically like you see this function here,
Yep.
and then you have this right here. So acquire a model. We wait there until we get a model.
Yep.
So there's that. This is all the early work I had to do. So acquire a model. If you only have one instance and it's being used, you got to wait
you're
for it
stuck.
to come back,
Okay.
right? Because it's a
Okay.
single instance, unless there's multiple instances of it. And then how long are you willing to wait to get your hands sort of on that model? I even track like how many active streams and stuff we have on that. But here you're basically saying, give me a model and I'm either going to get it in time or I'm sort of not.
Okay.
And that's what these little streaming functions, you have the streaming and non-streaming. Okay. And then essentially when you call this, you're sitting here waiting. If you get the model, you get to work. If not, then it sort of times out.
Okay.
It is what it is,
Yeah.
because this API isn't thread safe. One thread can use it at a time. So when you start Cronk and you say, you specify how many model instances, right? It's how many instances of that model are we going to load up in memory
To just have.
and now you can have concurrency in that sense, but you better have memory.
Yeah, you gotta have the memory for it, but you can. Okay, you can do it kind of at the same.
But on the Cronk model server, that number is always just sort of one because we allow multiple models to be loaded at the same time, one of each.
One of each model.
Technically, it's configurable because there are configuration settings. How many instances of that do you want, right? Mac instances of a given model. How many are allowed to be in the cache? But you got to have memory for all that stuff, right?
Yeah.
Do the settings are like, right? But this is where like a Florent comes in and can start tweaking performance and stuff. If you know you're only going to work with one model for this particular model server, then, right?
Yeah.
You definitely want this to be maybe higher because you're okay with having it.
Yeah, it could get
right? Because you can only have that one model in the cache, but we can have 3 of them. I don't know.
Okay.
I thought of all this shit already. So, but you can see what's happening here, right? So that's the limitation because it uses a lot of shared state inside this model data structure that it has.
Okay.
It's an API that's really like there's hidden state that's constantly being manipulated underneath. Okay. You can see here also like this is the context, which is not good. I need to pass a, I unfortunately need to break this API. It is what it is. Pass a context into it. So this logging is not zeros. Remember how it was zeros?
Yeah, it wasn't the trace ID.
Yeah, I just didn't, whatever. I've been breaking APIs. It's fine. I mean, I shouldn't. I versioned one of it way too early, but I didn't realize where this was going to go. Anyway, so we've done that. I don't care about templates or anything like that. I think this is good. Let's see where we're at. We're going to need some of this at some point. Let's do this. We're going to need these context parameters too. I don't know when, but we're going to need them. Should be able to just stay like completely generic right now. All right. Okay, you don't want to do that. That's fine. Okay, so let's see what happens now. Let's just go to like making a call. So let's say that we want to make this actual call to the model, right?
Okay.
We have this process. And again, I'm not going to try to parse anything. I just want to see some tokens coming out. So we don't have this LX thing yet, do we? So let's go back here for a second. I have an LX, a local context already before we get in here. Okay, init from model. Okay, this is what I'm looking for. Let's see what we need for this. So given that model we loaded and these context parameters, now we init the model. Okay, so we do the model load from file. We do the init model, init from model. That gives me an LX. I don't have anything to worry about projections right now. Don't worry about any of that. Now I come in here and I can come into this start processing. See what I need for this. Okay, now I need a sampler. So let's take a look at the sampler code here. I essentially need 2 things for the sampler. The sampler is the key to everything. It decides what the next token is going to be.
Okay.
And we need at least these 2 things sort of as part of the sampler. Everything else, you see how we add temperature?
Yeah, top peak.
I don't need to do that, but I need at least this. These 2 calls. So this is the sampler's job, is to kind of pick the next token as we're going token by token through a stream. So we need a sampler. That will be our sampler. Now, we still didn't do the prompt work yet. So let me go back and do the prompt work, because this will be the next thing to do. But I need a prompt, and I need a prompt within the scope of that template, right? So let's go back to chat for a second. You see some code here that says apply request to a Jinja template.
Yeah.
Right? Now, there is some code that Ron has here. Hold on. No. I gotta find the code where we're using the default one. No, I don't care about any of that. Well, maybe we just do this one by hand. Because, hold on a second. Let me go back here. When we first create the model, new model, I think there's some template stuff in here. Here.
Retrieve template.
Go to retrieve template. This is what I'm looking for. All right. This would take the default template.
Okay.
Now that we have a model, that will give me the default template. Okay, so that's my script, right? That's my template script. Let me just call it script for now, because that's what I call the field there.
Okay.
Oh no, wait a second. Model template. Oh yeah, default. And then if it's not there, we like manually just go right into the into the thing. But that should work there. Okay, so then if I go back to this apply template, right? Then see if script is empty, no template found. So now I got a script. Now, the problem with this code that I have here is that I took out the llama stuff and I'm doing everything with the ganja package, right?
Okay. Yep.
But I think that if we go back to the ISMA examples, he's using the raw. Oh yeah, I didn't even do the model free. Let's do that too.
The model free does what?
Freeze memory.
Oh,
Right.
okay.
I mean, might as well do things right.
Yeah. Sampler.
There's the template, right?
Yep.
And then what he does is
Chat this.
something here. Okay, let's keep going here. So I got the template, right? I'm doing the same thing he did. Model, chat, template. I have a template. Now, the next thing I sort of need is what he's doing here, right? He's creating a message of this sort of chat message. Now, I don't have this sort of hard-coded this way. I created this concept of a D, but we can still use llama here if we wanted to. ISMA here if we wanted to, right?
Okay.
Because I'm just trying to get from here to here right now. So let's say that I did this real quick. So this isn't the part I honestly care about. I gotta see what this line of code does here. So let's just say hello model, right? At a low level. Hello model. I'll just follow his sort of pattern here. But since I know I'm going to have at least one there, I'll do that. I don't need a system prompt for that. So again, I don't use his data structures. We use something called a D, which is a map, which gives us a lot more sort of flexibility.
Okay.
But I don't need that flexibility for what I want to accomplish here. He does have a function called chat. I don't know what this does. Oh, that does the actual chatting. This is the part I really wanted to look at. But he didn't apply chat template. Okay. This is the little piece that I need. We use Ganja for this piece, okay?
Okay.
But so we can call this the template, okay? And we have the messages. And then you're going to say add a system prompt, true. And then there's this sort of buffer. And then whatever came back, this is essentially your prompt. Okay. So if I just did this right now, just so you could see this for a second. Right? I'm not using you just yet. So let's move you. If I'm not using you, let's move you for a minute. Okay. So right now what I'm doing is I'm loading the model from the file, creating the sampler, which I'm not using yet either. I must be using it. I'm using it there. We're not using it yet, right? So let's also move that here. I'm getting a template. I've got some messages. And I'm taking this hello model prompt and I'm creating a prompt from that using the templates, using that chat template for the model, right? So if I run this, I should put some logging around what it's doing. That's what a prompt looks like in prompt speak, right?
Okay.
And that's what Ganja is doing with those templates and fixing. And when it gets to tool calling, that gets a little bit more complicated. But you can see user, hello model, start the assistant, hey, and then it's like, it's your turn, right? So what we could do here.
So that's like directly talking to the model.
That's what we have to send to
Nothing
the
in
model.
between.
We have to send that syntax into
Yeah.
the model for it to properly work consistently, right?
Got it. Okay.
So that's what the whole that's what the whole templating system is about. And it's really flexible that way. And sometimes those internal templates are broken most of the time. So model for file. Yeah, we haven't done that yet. Just from an output perspective, look at that. Okay, so that's our prompt, right? That's what we're going to be sending into the model. There's a lot of work that goes behind that, right? You're seeing a very simple thing.
Yeah.
I'm using the default. I don't use that. I use Ganja to actually produce that, but I don't need it for this particular exercise here. Okay, so again, we're just going raw here.
Yeah.
At this point, right, we've loaded the model there. We've got a template. We now have a proper prompt. Now we've got something we can feed into the model.
Okay.
Okay. The next step now, again, if we look at what Ron is doing, is the tokenized call. So if I come back here for a second, I want to make this tokenized call. Now, in order to make the tokenized call, I do need this thing called a vocabulary. Now, there's a API for that right there. All right.
And I'm guessing tokenize is going to convert from that sort of prompt that syntax into like plain English or
No.
into a token?
We're going to take the prompt. Hold on a second here. The idea, and I haven't needed you yet. So let's move you still. Haven't needed you yet. The idea, I haven't needed you yet either. Interesting. Let's move you here. All right. Okay. I want to look at what we do here too, but I don't understand operation variable anything, dude. There's not a. Why does Ron do this then? Or maybe Ron doesn't do that. I did that. No, it is a slice. Interesting. Declared not used. I know. Declare not used. Cannot call length variable of int32 in a function. Tokens is a slice. All right. Okay, I'm missing, my brain is missing something here because llama tokenize is returning a slice, right? And it's a token value, that's fine. But I don't know why I can't use length of some slice, right? So wow, there must be something here called length, and I don't know what's going on. Ah, there it is. That will screw you up every time, won't it? Okay, so what we're doing here is we're taking the prompt and we're turning it into tokens. Tokens related to the language, right? The token language that this model speaks. So we got to tokenize. Everything has to be tokenized because the model only processes tokens. So okay. If I run this, okay, that basically produced 10 tokens.
Okay.
All right. That we're going to need to process. Okay. Now, one of the things I wanted to look at while we were doing this, this is the process chat request. And this is my start processing. It's like kind of where we begin. And you can see here that I have a sampler, right? And I'm not using the sampler yet. I'm using it down here. And, you know, based on that, actually, might as well do that. Can move the sampler there, right? I don't think that comment made any value. But I passed the sampler back out, even though I may not be using it there. I'll use it somewhere else. So let's just leave it. All right. That's just the way this function works. Okay. So we can see here that I do the tokenize and I do the input. And now what's, we're going to be following this path here. Okay. The next thing to do now is we've got to decode all these tokens. Now, there is a special parameter called nbatch.
Okay.
And from a performance perspective, you want your nbatch. Let's take a look at that for a second. If I go to config here. Okay.
I think we were running into this back. I forgot what it was, but we were trying to do something with a llama.
So by default, okay, this is the documentation for these sorts of things. You have a logical batch and this physical batch.
Okay.
Everybody says that you should have the NU batch about 512 bytes and your N batch around 2K, depending on what you're doing. So if you want low latency, small batches, these are your numbers. Long prompts. The size of this could determine your performance. If it's too big, it may not necessarily speed you up, though one would argue that this says long prompts, an N batch of 2K with an NU batch of 5, faster prompt injection, because you have less iteration that you're going through to decode all this stuff. And so this is all the stuff that guys like Florin have to freaking tweak and stuff. You can see in Kronk, I have the 2K default and a 512. And what I do is if the number of tokens is greater than 2K, then I have to decode all this stuff in a loop.
Okay.
So if we come back here, you see I'm going, okay, how many input tokens do I have? What's the size of my N batch? If it's under, I can do one call to decode. If not, I got to do multiple calls to decode. Remember that model has state underneath the covers, right?
Yeah.
And so, but this is going to be super small, right? No matter what that is set to. So what that means to me is we should be able to do this. Now, I needed this init from model. This is the first time we're seeing this. I need this. Okay. And I haven't needed the sampler yet because I'm not trying to sample output just yet. What I'm trying to do is process all these input tokens. Okay.
Yeah. That makes sense.
Now, this is going to be super small. So I should be able to do this all in one sort of decode. So you do a batch. So you take these tokens and you get a batch, and then you take this batch and you decode it. When it's bigger, what you see me do is take a chunk of that max size that I have for this, and we just go, bah, 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 bah. If not, then this is where things can panic if we're not doing that right. So what we've just done here is decoded all of our input tokens.
Okay.
Okay. Now, once we do that, the next step, now let's see what Ron is doing, right? Ron's going to be doing, it should be doing the same sort of thing here. My guess is he's doing a batch one. He gets the batch. And then he does the decode. And then he's calling the sampler. Now, my guess is when I come back to start processing here, right? After start processing, I now get into a loop. And it would come to this sort of standard, not GPT processing, but standard processing. See, I'm passing it the context and the sampler.
Okay.
Right. And my guess is the first thing I see is the sample token. Right? That's the sample. And if I go into this little function that we have, sample token, there it is. So my guess here is what we're going to need to do is I need my sampler now. And sampler. Right. So now what we're going to do is using the sampler and the context, because the context now, right, we need this model. We've done the decoding. Now we say, okay, give me the next token for output. That's what this is doing.
Okay.
All right. Now there's a chance that that sort of fails. So this checks if the token is an end of generation token. If it is, we return a
end of
file. We need the vocab. Okay. And then there's this function called token to piece. We're given the vocabulary. and the token. Now we need the buffer. Now I wonder what Ron is using for a buffer. He'll have a
right there. Yep.
small one. That's fine. We won't need much, but let's just go there. Given a buffer, it's complaining on the L, and it's probably complaining on the buff because we already had a buff. So I'll just do L2 for now. And then L strip 0 and special true, okay, which means handle special tokens differently than regular tokens. This now gives us some content, the first sort of token that we cared about. So if I do this, L2, as long as it's not empty, right? And what we can do in our little main here is just check if errors dot is, and then just return, right? Okay. This should print the very first token for the response. So let's just do that right now. And I would say, yeah, that should give us that. And we'll just see one sort of word coming out of here. But what I want to do is the following. No, not going to help me here. That was the start processing, but I wanted to be in here. Okay, so you have to remember that in our Gronk code, this is in a loop here.
Yeah.
Okay.
Yeah. And that's why here we'd only get like the first.
Now if I go back to standard first, yeah, we did the sample token. Then we did process that. And then I want to go back to standard here. Because then what we're going to do, right, we need the batch. Okay, so I need to look at one more thing. When we call standard first, I return a batch. I don't have a batch here. I return an empty batch on this path, I guess. Interesting. That's fine. So standard first. All right, let's see something here. Stuff gets really interesting. Oh, that's what I needed. All right, let's just see this first. So I should get something out now when I run. Nothing spectacular. So I don't like what I saw here. I wouldn't have expected that. So I'm definitely doing something wrong, I think, here. Let's go back to Ron's code for a second. We don't need this path at all. So what we did already was we did the batch get one. We had a batch. Let's just break this down for a second. So we have a batch. We decode that batch. All right. We have a batch. Now this is a loop, right? I can iterate just to keep it super simple. Maybe what I'll do is I'll move this here for a second.
Okay.
And because this we just need one time. And I don't think I would need any other sampler. You know how Ron created some
up there?
Let's do what Ron did here for a minute. Just because I'm doing things a little differently, but I don't need... Yeah, I just need these two. Let's do it the way Ron did it real quick.
Okay.
Then we can go back into the cron code. And then that's the default that we had, remember? So the way I'm doing it here is I've got the sampler chain default. He's got just default sampler params. I would think these two are the same, but we'll try them both in a second. I'm just going to comment that out. Then I come back here. This is the part that I want to see. So we do a batch, we do a decode. Now the decode he has in a loop. So what we can do right now is just say for range, just 10 iterations for now.
Yeah.
All right. And then he does a decode. He does the sampler. We check if we're EOG. Then we do this. We get the content. We can print it out. And then this is the next thing. I need another batch after that. I'll just print it out. And then what we do is get the next batch, and then that batch is sort of decoded. And we'll do this sort of 10 times. And right now I'm just going through 10 loops. Let's just see. So something's obviously broken here, right?
Yeah.
Because we're not getting the we're not getting a response. My brain thinks it's potentially the samplers thing, but like I said, I'm following what we're doing sort of here too, right? But this is why I wanted to go through this exercise, because even though I've got all this code and it's working and I've done this over 2 months, this has never been like 100% sort of solidified in my brain. Now, this is what we're going to do. This is where the power of AI comes in. So I'm going to do the following. Save some time. A very basic program using Yzma to just show sort of just show the APIs work. Doing something wrong because the output I get is oh, damn it.
AI.
Let's try it now. Dude, that would have taken me forever. Okay, perfect.
There it is.
Oh, such an idiot. I'm like, I know this is right, but I don't understand it. Okay, so you see what happened there now, right? Let's also do... Okay. So now I want to go back to the code I had. I think it's cleaner. Yeah, perfect. Okay, good. So now what you can see here is that we can do this ranging, but at some point we should be able to know that we've hit the end, right? We should hit, let me just see what happens if I do this. I don't remember. I have to go back and look at the cron code. I don't know if that's enough to say we're done. Yeah, it was. Okay. How cool is that?
Awesome.
So at its sort of lowest level here, so we get a batch, we have our tokens, right? So let's go back through here now and look at this one more time. So, okay, so here so we load the model from disk into memory. That's what we're doing here. What is that?
Daniel.
Oh.
Big red deployment.
Oh, we're almost done anyway. Then here, what we do is we process the input and turn that into a proper prompt, right? So that's what we did there. Then here, right, we tokenize the prompt for processing.
Yep.
Which we did there. Then here we create a context for processing the tokens. This is really like single-threaded stuff in here too.
Okay.
Right. And we need a sampler to determine like what the next sort of output token is going to be. That's what the sampler does.
Mm-hmm.
All right. Then we process each sort of token at a time. So we're giving it the tokens.
Yep.
It internally in memory knows where it's at. It processes one token at a time. That's why you see like the way it's coming out. Time and produce a result. And so we process the next batch from there. We decode it.
Yep.
Then what we do is we ask the sampler to pick
The
what that next word's going to be.
That makes sense.
Are we done? If we're not, then we take that token, which was supposed to be the next word, right? So okay. All right, process the next token in the slice, right?
Mm-hmm.
Turns a batch for a sequence of tokens, right? Then we will. I'm going to do this. Decode that batch and pick the next output token, right? Is the model done responding? If not, convert the token to a human sort of readable word, right? Convert that and check it's not empty. That would also signify that we're not getting any more. We print it and then we say, right, get the next sort of batch from the, but we do it off of that token that came out, right? So this is what I'm going to do. This is where things start to break down for me again, right? So I'm going to go back and say, okay, read the comments from lines 91 through 116 and please correct any mistakes about what the code is doing.
Let's
What's confusing about the APIs is everything's happening internally inside the scope of this context. And so you don't really see it, right? So they fixed this stuff now. So create a batch from all input tokens for the initial processing. Now, decode the batch to process tokens through the model. Sample the next token from the model's output distribution. Check if the model produced an end generation token.
Yep.
Get the string content and check it's not empty, and then create a new batch with just the sampled tokens for the next generation. Okay. And this is essentially your low-level iteration and loop. All right.
Okay.
Like
interesting.
And it's in its rawest form, right?
Yeah.
This right here is where it all sort of happens. Right. Now we could argue I could move this here, let's say, from a processing perspective, because this is initialization.
Yep.
Right? This is template initialization. Then this is getting an actual context to sort of use in a sampler. And then this is where we actually start to process things. I would even argue that maybe
that would go underneath.
Would even go underneath here.
Yeah.
Right, from an ordering perspective. Because we'll load the model, then we'll create a context and all that. Then we'll create the prompt. When I get the prompt, I guess I get an automatic character return line feed. Then we got the number of tokens we're going to be processing, input, right?
Input, yeah.
And then we go ahead and create a batch from all input tokens.
And then loops.
Now, if I go back and look at cronk for a second, we go back and look at cronk for a second. All right. And this is the process part here. Or actually, I always like to start with chat. So if you're using projection files, you have to do some more there, but we don't need to worry about that today. So we come back now into all this initialization's done on new, right? So we have all that. We get a sampler, all that's being done on new. So if I were to open this back up, we would see on new, we're loading the model. And then at some point, we'll be initializing, we're getting an L context, so we can't do anything, right? By the time I call this function that I want to look at, we already have an L context. So here. So you want to do some chat streaming? Okay, you need a context to do that with. We now create a context from a model that's already loaded, right? We do the templating stuff.
Yep.
So, but we're using the Ganja instead of the Llama API calls to do that. So this all got replaced with Jinja at some point. Then we come into process request, right? We do a start. The start processing now already has the prompt. So what did we do? We create a sampler based on your parameters. So now we get a sampler. We then go ahead and
it moves to tokenize.
We already did this. So one could argue that this should be here, because once the vocabulary doesn't change, right?
Okay. Yeah.
All that could be sort of done here. We get a
It's not
vocabulary.
really processing.
Yeah.
No.
Right. Might also make more sense to move the sampler here, just because it's more like, hey, now we need it, right?
Okay.
So just do this right. So we could argue then that all of this is sort of initialization, right? Cool. That's what all that's doing, right? Then we turn everything into a proper prompt. And we tokenize the prompt. And maybe we'll put this in its own. All right. Construct a sampler for token processing, right? Maybe we'll have the AI come up with some better things there. Now this is our loop, right? Process each token and produce a result. So now this is what you see here, right? We've done the tokenize there already. In fact, like if we were going to keep the order, let's just say we're going to keep the order.
Sampler would be right above it.
Right? Like at least the way I'm doing it, right? I get the sampler there. Then I tokenize it. Now in here, there's the tokenize, and then the next thing you have to do is do the batch. So again, we talked about there's two ways to do that depending upon the size of all that, right?
Yeah, we did the one.
Okay. Then when the start is done, right? The start is done up here. Now we have the very first thing that we're going to be processing, the first iteration. And when I look at that sample token, right? It's sort of this right here, this here. Based on the, like, I have a little bit of a different order going on there, but we have that. See, oh, we did that already on the other side, right? That was the first. So this is the first sort of sampling. What's interesting to me is this decode call. If we go back here, I wonder, hold on. Where are we? Let me try something. May not need to do the decode there. I don't know if this is going to break. I think it broke. All right. So this is what I wanted to check, right?
Yeah.
So we needed the decode there, be the first decode, right? So that worked here, right? But when I come back and I look at what I'm doing here, we go right into the sampler.
Yeah.
EOG token, I come back. That's called a sample token. Oh, I have the decode here already, right? Okay, that's the decode. So in my code, I had the first decode already happening here.
Okay.
And I'm doing that also so I can figure out what the pre-fill non-media time is. So this comes back and does the decode. So that's being done already here, right? One could argue that
Do it outside of the loop.
Just for the first one.
Yeah. And then, okay, and do it at the end.
Because if I do this, then if you notice what I did here, this decode is the prefill, right?
Mm-hmm.
Decode is the prefill. We've got the tokens. Just to have a little bit more per line, prefill. Prefill. People always want to know how long this part took.
The prefill?
Yeah, because this is getting all the input tokens in. It's the larger your context window.
Okay.
So the harder that ends up being, right? So this should still work. I just moving it, yeah, right?
Start and stop.
And obviously this is a really small prompt, but whatever, right? I mean, so you could say here, you know, form the prefill step with the input tokens, and now process the output tokens. And that's what we're sort of seeing here now. And that's the loop that we're doing. And then a lot of this code now, right? So that's the core of everything.
Mm-hmm.
But now a lot of this code is process standard. It's essentially reading what's coming out like a think tag, and trying to capture that so it can create some structured responses around that. So when we do this is the loading. I have to add some, I don't want to put logging here because it gets hello model. See, all that other code now is about, is the weather in New York City, tool call.
Yeah.
You see what I'm saying?
Yeah.
But with this little bit of code, you now have the ability to start parsing these things out. So you can have a better sort of API, right?
Yeah, interesting.
Now I'm going to ask the model to do one more thing. Review all the comments in and oops, and correct them or just clean them up. And then we're going to be done. So I'm going to add this to the examples because this shows you at the very low level sort of what it takes to process tokens and input tokens and getting output tokens, and right.
It's pretty cool seeing like the step-by-step. It's pretty complex.
But to build something like Kronk, now you can't do this. You need the Ganja because you got to work with those Ginger templates to have a little more flexibility, right?
Mm-hmm.
You got to add support for top P and K and blah, 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 and all that.
Yep.
And then this is the core of it all, but now you got to process this output.
Yeah.
And sort of structure, right? And now we have a nice little sample along with what I'll keep is I'm going to add this to the
diagram
README.
is nice.
Right? And we fixed also the packaging imports and structure because this is now much cleaner, right? So I have to add this. I'm not gonna commit this just yet because I gotta add now the new Zima.
Hmm.
But pretty cool, right? Like,
Awesome.
and now you saw this big ecosystem that we just built on top of it.
But it's basically
But
that at the
basically
lowest.
this code
This is
is
the
what
heart.
allows Kronk to be Kronk.
It's pretty awesome.
But you need a large amount of support on top of this to get it to really be functional on a usable level, right?
Yeah.
But there you are, right there. Pretty cool.
Very interesting.
Okay, kids, we're way out of time, but I think it was a cool video, and I'm gonna attach this video to the project too, so people can sort of also get a
Yeah, just us going over the architecture and how everything's sort of laid out.
yeah. All right, everybody, we're signing off. Got other things we got to do today, but it was a cool time. All right, we'll see everybody next week.